Hello everyone, I hope you're all doing well. So in today's video, we are going to go through the 2021 Specialist Maths Exam 2 for the Northern Hemisphere multiple choice section. Like always guys, if you guys want private tutoring in specialist methods, physics or chemistry, you can always email me through this email. I hope this video finds you well and helps you with specialist studies. Let's smash through this video. Question 1. The graph of cosine inverse 2 minus bx, where b is a positive real constant, could be what? Guess what? Just sub in a value for b, a positive value. So let's say let's sub in b equals 1. It's a positive real constant. And what would the graph look like? It'll be cos 2 minus x. Oops. 2 minus x. So just let's have a graph of this. What would this look like? And compare it to our answers. It's a really nice question, this one. So we know that cosine inverse looks like this. Isn't that? Let me draw with another color. So yep. Looks like this. Perfect. And then what's happening is it's reflected in the y-axis. So it's actually going to look like this. But it's also translated, in this case, 2 units to the right. But yeah, by some units to the right. So imagine taking this over here and just translating it some units to the right. And it should look like that. Which one looks like that? It looks like A is our answer for this one. Beautiful. Not too hard. Yeah, you can, use your CAS and straight away just sub in values. It should look like that. Next question. Consider the function f of x where this is f of x where a is a real constant. Okay. The graph of 1 over f of x will have 3 asymptotes if the set of values of a is what? So straight away, because it's a reciprocal function, we know that y equals 0 is going to be an asymptote. Remember, there's going to be like a plus 0 here. It's an asymptote. It's the only horizontal asymptote. So that's already one asymptote. So we need 2 more because remember we want in total 3 asymptotes. How do we get those 3? Well, those 3 are going to be vertical asymptotes. And remember, to solve for vertical asymptotes, we let the bottom function, so f of x, equals 0, and we solve for x. So if there are 3 x values, there are 3 vertical asymptotes. In this case, we want 2. So what we want to do is basically solve where f of x, let's use our calculator. No, not even solve, basically. Just because it's, just use a slider. So write this function, use a slider for a. And play around. So, for example, we'll try A, then we'll try B, we'll try C, we'll try all these until we see that basically where, I don't know how this graph, let's say f of x looks like a parabola, it crosses 2 times in the x. It means that there are going to be 2 vertical asymptotes. That's what we want. So let's do that with our CAS. So what I'm going to do straight away is go on, okay, so it's going to be basically absolute value x minus 3 plus absolute value x plus 3 minus a. All right. And here it is. So let's try the first part. The first one is just -3 and 3. Those significant points, just those points. Let's say -3. Let me zoom out. It doesn't really look nice here. Zoom out. Okay, what do we see? Absolute rubbish. It doesn't even cross the x-axis. There's actually no vertical asymptotes here. No vertical asymptotes. So A is wrong. What about B? B saying no solutions. Well, let's check the other ones before we get into that conclusion. The next one is 6 to infinity. So 6 included. So if I put 6 here, perfect. So 6 actually crosses that. Yeah, it crosses the x-axis twice, it looks like. One here and one here, right? Those 2, so 1 in here. And also to infinity, it said. So 6 to infinity. So if I put, let's say, 7, perfect. Look, 1, 2. So there's going to be 2 vertical asymptotes. 8, yeah, it's just getting translated down. Perfect. So C actually sounds very right. It looks right. What about the other one? It says negative infinity to 6, which is absolute rubbish because it's saying 6 is not included. And if you go, by the way, we know that when we go below, so if I go like -1, it's above. So no, it doesn't, yeah. So D is wrong. What about E? It's saying from -3, so -3 to 3. Now, absolute rubbish. It doesn't even cross the x-axis, so there's no vertical asymptote. So the only one is actually C, where it's 6 to infinity. Beautiful. Next question. The graph of f of x, where s and t are real constants, will have no vertical asymptotes to what? It's basically like the same question. Can you see how it's a reciprocal function? We're talking about vertical asymptotes. Remember how to find vertical asymptotes? The bottom function. So we want it to have no vertical asymptotes. So this function, we don't want it to have any solutions. Because it's a quadratic, should we just find the discriminant where it's less than 0? Because less than 0 means that there is no asymptotes. So let's do that. So b squared minus 4ac is less than 0. Okay, less than 0. Where b squared is s squared minus 4, a is 1, and c is t, must be less than 0. So s squared minus 4t less than 0. negative 40 less than s squared, sorry, negative s squared. Divide both sides by negative 4. Remember, if you're dividing by a negative number, the sign changes. There it is. So t is greater than s squared over 4, which looks like question 3c. Perfect. Next question. The expression this has a partial fraction form of this. The values of a and b, where a and b are non-real constants, are respectively what? A really beautiful question that you can just do with your CAS. So what we have is we have the partial fraction form, and we want to get back to this over here. This one has a common denominator. It's like basically all, it's just common. We want to find the common denominator, and we should get this function. Let's do that with our CAS. So what I'm going to do straight away is I'm going to go to my CAS, go menu, number, and go to fractional twos, and we'll go to common denominator, and we'll write that partial fraction form. So it gives us a common denominator like that, minus 2x minus 1. I'm going to copy this actually whole thing. 1 squared. All right, enter, and this is what it is in terms of common denominator. So let's write that down. 2 minus 7x all over 4x cubed minus 3x plus 1. We know this bottom part is equal to this. So guess what? We can just kind of substitute that to that. So it's just the same as 2x minus 1 squared, x plus 1. Guess what? What is our a and b values? Well, a is negative 7. So a is negative 7. And b is equal to 2. Which one's that? Negative 7, 2, which looks like D. Done. Next question. The complex number z equals b plus I, where b is a real number, has this property over here, where, of course, argument is z to the power 7 is equal to the argument of z. A possible value of b is what? A really, really nice question using your CAS. Let's use our CAS. Guess what we do? We're just going to define z, and we're just going to sub all those b values and see which one's true. Let's do that right now. So what I'm going to do is I'm going to, define z. So it's basically, let's sub in the first b value, which is negative root 3. So negative root 3 plus I, of course, plus I. And what I'm going to do is I'm going to, so argument, I can write, arg of z to the power 7. It's argument is just, again, just known as angle, z to the power 7. So I'm writing the statement, has to equal to the angle of z. I enter, false. So the first one's actually wrong. What about the next one, where your b value is 0? So this is 0. Putting it in there, false. It's not that one. Let's try C. So C states that it's 1 over root 3. So like 1 over root 3. True, that's your answer. So actually 5C is your answer. Beautiful. Question 6. Let's have a look at this one. If z is a non-zero complex number, then cos argument of z is equal to what? So let me explain this very, very easily. Think of it like this. Okay, imagine z is x plus y, yeah? Let's consider as x plus y a complex number, which we can write, by the way, the same as, we can rewrite it as like, r of cosine, theta, plus I sine theta. Where, of course, this here is just the same as x. So this part over here is just the same as x. And, of course, this is your y, which is that part there. Yep, that makes sense. Absolutely makes sense. So let's actually draw this in a plane, like a, Argand diagram to represent what's happening here. Okay, like that. Okay, so let's say this is z. Right here, let's say this is z. Done. This is z. Now, what's arg of z? Argument. It means the angle of z. Can you see? From the horizontal, can you see? Angle of z. So basically, our arg of z in this case, let's say arg of z is equal to theta. So what we're saying is, hey, find cos arg of z. Do you know how arg of z is theta? We're just trying to say, hey, let's find cos theta. So that's what we're actually trying to find, which is actually not hard, because breaking it down, you realize, okay, so you remember how this is, basically this is x, basically. So remember this, like x is our cosine here. And of course, this here is the magnitude of z. This part is the magnitude, of course. And so it's just using basic trigonometry. Of course, this is your hypotenuse, this is your adjacent. So because I'm going to make an expression of cos. You know how cosine then becomes theta is adjacent, which is our x, over your hypotenuse, which is square root of z. Okay, now think about it. X, yeah, which is this x over here. You remember they're equal. Can we write x as, if I was telling you, hey, what's the real part of z? You'll be like, oh, isn't it just x? Yes, so we can actually substitute this x with the real part of z. There it is. So this is the form that we want to write it in terms of our question here. That's what they kind of have it. So so it looks the same, but there's a problem, a big no-no. They've taken the absolute value. Why wouldn't we take the absolute value? So basically they're saying, hey, just take the absolute value of this whole thing. Why do we not want to do that? Consider this. If z was over here, can you see how we have a negative x value here? You see this is our negative x value. Imagine that your x value is negative, yeah? Imagine this here, x value is negative. Doesn't that mean our cosine theta is negative? So our cosine theta would become negative? Because think of it like this. So imagine, like, let's make up one. Let's say to make it easier, -1 plus I. Can you see how -1, we're in that component, yeah? If I put all the components here, is cosine theta going to be positive? Remember, is cosine theta going to be negative? That's what we want, yeah? Remember, that's our goal. Our cosine theta has to be negative in terms of explaining these over here, yeah? Our x coordinate is negative. It has to be, the cos has to be negative. So let's substitute it in here. What's the real part of z in this one? It's -1. And the absolute value of z is basically, root 2, of course, when you take, And then what you're saying is, hey, take the absolute value of it. If you take the absolute, it becomes positive, which is rubbish. Because remember, cosine theta has to be negative. So you can actually, in these cases, some cases won't work with this one over here. So absolute rubbish. B, real of z is square root of z times conjugate of z. Well, okay, so what's the square root of z? You know how we consider z as x plus y? And so the conjugate is x minus y, and so expanding that would give us x squared so basically x squared plus y squared, basically. And isn't that just actually how you would, if I was telling you, hey, find the magnitude of z, you would be like, hey, isn't just the, square root of x squared plus y squared? Isn't that true? So this here is the same, yeah. So this is the same. So this part over here is the same as, the magnitude of z. So it's actually B as your answer. I hope that makes sense. Next question, 7. With a suitable substitution, which is cos 2x sin 2x, it can be expressed. This is a really, really nice question. Wow, really easy. So what you're going to do is use substitution. So let u be the bottom function, sine 2x, derive. So dx is 1 over derived sine 2x, which is basically 2 cos 2x. Of course, don't forget that du. So let's re-express this whole thing. If I want to get this in terms of u, so I'm going to put pi on 2 in here. So pi on 12 times 2 is pi on 6. What's sine pi on 6? A half. Doing the same with the pi on 6 here, sub it in here. So 2 times pi on 6 is what? Pi on 3. Sine pi on 3 is root 3 on 2. So let's write it cosine 2x. 1 over, what's sine? You remember how sine 2x is u, so it's u squared. And dx is expressed as that, half. Cosine 2x du. You can take those out. We can actually take the half out, this half constant out, and we get this expression. Wow, it's a really nice question. Du. So which one looks like that? Okay. Looks like 7A is our answer for that one. All right. Question 8. So, okay, we have the differential question that has the diagram above in its direction field as well. Not too bad. So what we're going to do is just pick a point that's actually nice. Like, for example, I always like to pick where the gradient is 0, some points where the gradient is 0. Like, for example, what I'm seeing is if I take this coordinate, which is over here, which is like 1, 3, basically. Yep, is that right? 1, 3. And can you see how it's like close to a straight line? Basically, like the gradient is like close to 0, basically. So if I sub in that coordinate, you remember? 1, 3, they should give me dy dx to be 0, approximately 0. So let's try the first one. If I sub in 1, so 4 plus 3 over 1 for a12 minus 12 is equal to 7. Negative 11. So this over here is like, it is like negative 0 point something. So it is in that 0 part. Like it could be this one, by the way. It could be. So we're Yep, because it's like 0 point something. It's very small. Let's try B. Also sub that in there. 1 minus 4, 8, 12. So 12 over 4 plus 3, which is negative 11 over 7. This is actually like negative 1 point something, which should be like a down gradient like this. It shouldn't be straight. It shouldn't be like a horizontal line. So absolute rubbish. That's not right. Let's check the other ones. So C is, if I sub that in, it's 3. 1 plus 12. 1 over 13. This is actually very small. It's like 0 point something. So it could be that one. Could be also C. It's approximately that 0 where this gradient would be 0. And so let's try D. So D is 1 minus 4, 8, 12. So 12 over 4 minus 3, which is negative 11 over 1, which is, again, rubbish because, remember, it's supposed to be approximately 0. This is, the gradient's negative 11 in this one. So it's not D. Let's try the last one, which is 4 minus 3 over 1 minus 4, 8, 12, 12. 1 over negative 11. So this is also close to 0. So it could be A, C, or E. So let's choose another point that's going to really distinguish between all of them. So I'm going to pick another point. Let's see. Look at these points here. I'm going to actually try to pick like 1, 0 here. Can you see how like 1, 0 where the gradient is actually close to positive? Can you see how it's positive a little bit? It's slightly positive. And it's a really easy point. So like 0, negative 1. Let's sub that one in there. Let's try it on A. So 0, negative 1 would be basically negative 1 over negative 4, negative 1, which is negative 1 over positive 4, which, remember, it's the gradient is slightly positive. Why is it negative? So it's not A. C, let's try that also. 4, sorry. So it'll be negative, oh, let me take that out. Okay. Positive 1 over negative 0. 4, negative 1. Again, this is also negative. So it's actually the same. So it's negative. So not that, and it should be E. So let's try also E just as a case. Positive 1, negative 4, negative 1. Yep, that works. This becomes positive. So it's actually E as your answer. Really nice. Wow. Question 9. Let's have a look at this. Consider the differential equation dy dx 2x plus 1, where, y of x of 0 and equals y 0, using Euler's method with step size of h, which of the following is equal to y2? A really genuinely nice question. So we know that Euler's formula goes like this. So, where it's xn plus 1 is equal to xn plus h. Yn plus 1 is yn plus h, where, you have fxn inside. Where, of course, f of xn, so f of x is your differential equation. So in this case, it's 2x plus 1. Let's do it. So we're given at x0, we're just given x0 and equals y0. So we know these values already. So we want it in terms of those. So first, let's find x1. x1 is going to be what? So imagine subbing n equals 0. So what's xn? It'll be x0 plus h. What's y0? What's y1? Y1 is y0 plus h. F of x, where you sub in, of course, x of 0. So it'll be basically 2 x of 0 plus 1. Done. Let's find x2. So x2, of course, is, so x1. So x1, which is, of course, x1's that. So x0 plus h, if I have not made any silly mistake. So wait, x2 is when you sub in 1. That looks right. So if I subbed in 1. Okay, beautiful. Yeah, because I just don't, oh my God, I don't know. I just had a brain fuck for some reason. Okay, yeah, so it's x1, so it's x0 plus h, so it's x plus 0 plus 2h. Okay? Y2 is what? So y2 is your y, so it's going to be, of course, your y1, which is this whole expression. So so let me write it nicely, because that's what I want to find. Y2 is y0 plus h to x0 plus 1, so that's y1, plus h, then 2 of, so you sub in now x1 here. So x1 is x0 plus h plus 1. Why did I write that plus 1 there? Yeah. What am I? Sorry. I don't know what just happened to it. Yeah, x plus 1. Close the bracket. And that looks, if I'm mistaken, that looks right. Yeah. So now just kind of expand it because it's all expanded. And that's it. Wow, you just need to be careful with the algebra here. Don't do it too quick. So you don't want to make silly mistakes here. So like 2h x0 plus h plus h, y2 is y0 plus 2x0h plus 2h, because these will, and then plus 2h x0 plus 2h squared. And so a little bit, let's see if we can cancel. Let me just rub this all out. This part here I don't want anymore because it's taking some space out. Okay, we get this little expression over here. So y2 is equal to y0. Add these up, which is plus 4x0h. So these cancel out. Plus 2h squared plus 2h, which looks like looks like 9a. Wow. Okay, perfect. 10. Let's have a look at this. A tank initially contains 20 liters of water in which 0.2 kilograms of salt is dissolved. Fresh water flows in at a rate of 6 liters per minute, and the solution is kept uniform by stirring, flows at a rate at 8 liters per minute. The mass of salt x kilograms in a solution in tank after t minutes is related to t by what? A beautiful question. One of the most common questions you get, like the solution questions. So how do you do this? Well, it's in terms of x. So okay, we want to find basically first dx dt. To find dx dt, which is of course the mass of salt over time. So yep, dx dt is of course, to find it, you need to find dx dt that comes in the minus your dx dt out. That's what you want to find your overall dx dt equation. So how do you find your dx dt in? Your dx dt in, so dx dt in, this is the formula, is the rate in times your concentration. Yep, so the rate in that's coming in times the concentration. And it's the same case for dx dt out. Dx dt out is the rate that's coming out times your concentration. And we know that concentration is just your mass, in this case, mass over volume. That's what it is. This is your formula for concentration. Well, let's find dx dt in here. So what's my rate in? So it says fresh water flows in at a rate of 6 liters per minute. So the rate is 6 times, what's the concentration? Well, they say fresh water. There's no salt dissolved, so it has a concentration of 0. Which means my rate, overall my dx dt in, is actually 0. So I'm going to put that 0 there. Okay, let's also find dx dt out, which is the rate out. It says flows out at a rate of 8 liters per minute, so 8. Times the concentration. Well, they haven't given us the concentration, but we can easily use this formula over here where it's mass over volume. Well, mass is in terms of x in this case, and volume. Well, to find volume, we need to remember that volume is your initial volume plus your rate in. So that's rate in minus rate out times t. So this is the formula. So putting it in this over here, so it's V. So what's my initial volume? 20 liters. So 20 plus rate in. So our rate in was 6. We're going to minus it by the rate out. So 6 minus 8, which is -2. So it'll be -2. So basically negative 2t. Done. You can see that there's a common factor of 2. So like we can take a 2 here. We can write it like this. See how we can take out this here. Substitute with that, and we can actually cancel out that one with this. It becomes a 4. And just, yeah, it's going to be 4x on top. So this is my dx dt out. They're done. Now remember what we do to find your overall dx dt, we minus them. So it's your dx dt in, which is 0 minus 4x all over 10 minus t. Done. So this is my formula. Let me just rub this out there. Okay. Now, of course, we want to get it in a differential equation, like how, okay. So we know that there's, you know, it's in terms of x and t, so we have to use separation of variables, easy. So, of course, we can write this x as, you know, times here, right, as that. And so remember, you know, the x is on top here, we just have to reciprocate it. So this one, it'll be 1 over x dx. And then integrate this whole expression, which is -4 all over 10 minus t dt in terms of dt, which one looks like that. Okay, so the 4 is actually, for all of them, it's positive. So what I'm going to do is, I'm just going to say this is t, so I'm going to put it at the bottom, so it'll be t minus 10. Take that 4 positive out, done. Which one looks like that? So, 4. Alright, looks like D. Done, so 10D. Question 11. Let A and B be arbitrary non-zero vectors. Which of the following statement is always true? So let's have a look at the first statement. The magnitude of A plus B is greater or equal to the magnitude of A minus B? Rubbish! There are some, no, wait. That's not always true. Like, for example, if you have, let's make up vectors that would make sense. So if I had, like, let's say, if I had A, which is, let's say it's a vector I, just I, yeah? And if I had B, which is just negative I, let's apply it to this statement and see if it's true. It's not true because what's going to happen is, let's see, if I add these vectors up, of course, when you add them up, what's going to happen? It's going to be 0. And if you take the magnitude of 0, it's going to be just 0. Is 0 greater or equal, or when you to minusing them? So what's this minus that? Isn't it just going to be 2i? And if you take the magnitude of 2i, it's going to be 2. Is 0 greater or equal to 2? Rubbish. Statement is wrong. It's not always true. Be careful. They're trying to hear. Okay, let's have a look at the next one. The magnitude of a minus b, so yep, is less or equal to a plus b. So I'm not really understanding, like, first what I'll do is kind of switch it around because it's so much harder to look at it. So it's saying, let me just rewrite it nicely like this. So a plus dot b. So can you see how I'm switching these around? Because I also have to switch an equality sign. So greater or equal to a minus b. So what it's saying is if you find the magnitude of a separate a plus dot a. So yeah, if you find the magnitude of a and the separately and also b, it's going to be greater or always equal to a minus b. I mean, this statement kind of makes sense. Like, it does make sense. Like, if you find the magnitude of, like, for example, let's just make up one. So let's say if I had, let's use j, k also. Like, if I had I plus j here and to say b is negative I minus j. So if I put it in the statement, okay, yeah, it makes sense. I think this is something called triangular equality. Wait, so look, if I sub that in there, like if I sub this in there, so let's also apply the statement. So it's going to be root 2 here. This also would be root 2, so it'll be 2 root 2. So on the left hand side will be 2 root. Is it greater or equal to when you're minusing these? So minusing them would be like 2i plus 2j, and then you find the magnitude of that, which is just basically 4, which is 2 root 2. No, so they can add, no, the statement works. Yeah, 2 root 2 is equal to 2 root 2 because it can be greater or equal. So this statement works for that. So that equal sign works. I see that equal sign. Wait, look at this. These are the same statement, but this one's non-equal. So this one's rubbish because we just tried a statement that we can have them equal. Like, it makes sense that they can be equal. Yeah. This one's saying, it's the same statement, but it's saying, hey, it's not equal. You can never have something that's, they are equal. We just make sure, yeah, one's equal. So D is actually wrong. Let's just try another one because I want to see one. Let's make up one, like, let's say, rub this out. And let's make up one like I plus 2j or something. I plus 2j, just something, well, actually minus 2j. Let's make it. So if I put it in this statement, because I remember this is like triangle and but no one, like, never been examined on this. Yeah, so it'll be root 2. B would be 1 plus 4, which is root 5. Greater or equal. So minusing these two would be what? That'll be, the i's will be cancelling out. So j minus negative 2j. It'll be 3. Root 3, 3j, which you take it's just 3, basically. If you magnitude that. So 5 is what? 5 is like, let's say, because I know it's between root 4, so it's around, like, let's say it's 2.5 or something. Root 2 is like 1 or something. So, like, plus like 1 it's like 1.4 something. Yeah, this statement, like it's going to be like around 3 point something. Let's say around 3.8. 3.8 is greater than, 3. And we can actually put this in our calculator. Just let's also make sure that, that the statement holds true. Is root 2 plus root 5 greater or equal to 3? Yeah, it's true. So yeah, that this statement holds true. I'm realizing, yeah, that makes sense. So I have my, it looks like B would be the best. Now we're also going to check the other ones. Let's also check. So the other ones are just, they're the same, but the difference is this one's less, this one's greater. So, okay, the A minus B. Okay, just let's rewrite it nicely. Like, I like to make sure this is first. So A minus B is greater. So switch the sign, of course, when you're switching them. A minus B. So it's saying the magnitude of A minus the magnitude of B separately is greater than the A. This is rubbish, straight away. Absolutely rubbish. You can have, for example, you can actually have this. Like, for example, let's say you had, look at the wording here. So, because what you can have them equal. Like, you can actually have them equal. Like, let's say A was through I, for example, and B was I. Yeah, does this work? Yeah, this works. So, for example, if I put them in the statement won't make sense, because what's going to happen is if I find them separately, like the magnitude of A is 3 minus the magnitude of B, which is just 1, is it greater than minusing? So if you minus them, it's just going to be 2i, which if you find the overall magnitude is 2. It's 2 greater than 2. Rubbish. Absolute rubbish. And even the same case here, because can you see how it's the same equation, but this one's saying, hey, it's going to be, like, it's saying it's greater. It doesn't even have an equal sign, this one too. So this one would be like this. It's 2 less than 2. Rubbish. Only B holds true. I'm saying B, but that's how I would approach it. I would put some values in, think about it, break them down, yeah. Okay, question 12. A particle has a position vector of this. The total distance traveled by the particle from t equals 1 to t equals 4, correct to 2 decimal places, is what? Really nice question here. So we just have to, so distance, so use our formula. So we know that it's from, so we're going from 1 to 4, so time. And remember, to find the distance, we know it's going to be like your dx dt in squared plus your dy dt squared dt. So it's your parametric equation. So what's dx dt? Well, our x in this case is t to the power 3. Our y is 3t squared. So our dx dt is what? Is 3t squared, and your dy dt is 60. So putting them in here, of course, making sure that you square them. So what's this squared? It's going to be 9t to the power 4 plus, then squaring this will be 36t squared. So let's put this in our calc and find what it is equal to. All right, 1 to 4 square root 9t to the power of 4 plus 36t squared dt. Enter, and it's 78.26, which is looks like me. Perfect. Question 13, and the scalar resolute of A in the direction of B is what? What a beautiful question. So we're just trying to find the scalar resolute, which is just A dot B over the magnitude of B. So let's define these vectors over here in our cast. So A is going to be defined as, so it's 1, negative 2, 1. B is defined as, oops, it's B, yep. 4, negative 4, 7. And I'm finding, the scalar resolute, which is the menu, go matrix. We need to find the dot product, which is A dot B, and norm means magnitude of B. Enter, so it's 19 over 9. So it looks like D is our answer for that one. Question 14. A jet of mass 80,000 kilogram accelerates from rest in a straight line along a horizontal runway to a takeoff speed of 75 meters per second. The thrust force of the engines is 200 newtons and 200,000 newtons, and the resistance force acting on the jet total is 100 velocity newtons, where v is the speed of the jet in meters per second. The distance in meters needed for the jet to take off is closer to what? So let's draw a diagram. So imagine this is your ground. This is your horizontal ground. And say this is your jet. Let's draw a block here. So this is your jet. So we know that it starts, so okay, let's draw this over here and duplicate it. And this is where it's at its end when it's going to take off. Okay, so it starts from rest, so E equals 0. Yep, and the takeoff speed is 75. Okay, so your final velocity is that. We know that it has a thrust force, so like basically its thrust is 200,000, so 0, 0, 0. And the resistance force, so resistance is what? 100 velocity. So, okay. So, yeah. And what we're trying to find is the distance. Not too bad. So, what we're going to need to do is we can actually find, so we know we have, let's find the total force. So, these are the forces. Well, we know that the total force, so the sum, well, all forces is equal to mass times acceleration. And we want the acceleration formula because that's where we can more easily deal with it. So our force is just, basically adding this. Because it's going to accelerate to the right, of course, this is the positive direction. So adding these up, so this will be a positive, this will have because it's on the right, this is going to be positive, so 200,000. Minus, this one's minus because it's in the opposite direction, 100 V. That's your, of course, net force is equal to mass, which is 80,000 times your acceleration. Let's put this here. And let's try to put the acceleration formula. So divide both sides by 80,000. So we should get... All right, 80,000, done. We should get our acceleration. So you can rub these 100, so these will 200 here, 200 here, so this simplifies to this. Minus V, okay, is equal to A. Done. So this whole thing equals A. Perfect. So we know that acceleration, because we want to write it in terms of x because distance. So we can write, how acceleration, we can write it from your formula. It's the same as v dx, yeah? So if I multiply 1 over v on both sides, I get, so v will be here, I'll get rid of this v. And then if I reciprocate it, I get dx dt, 800 velocity over 2,000 minus v. Okay? And so now I can actually anti-differentiate this and I should get the distance. So anti-differentiate from, so this is supposed to be velocity here. Why is it time here? dv. So what's our velocities? So we're going from u equals 0 to basically the velocity to 75. So 0 to 75. Write this function there. 200 minus v dv. So this here, simplifying this should give our answer. So let's do that in our CAS. 0, 75, 800 v over 2,000 minus v dv. And that gives me 1,153.9. So which one is that? 115, basically 4. So 14 is B. Next question. So these are added to study design, mechanics is taken out, also momentum, so it does do 17. A particle moving in a straight line at time t seconds, where t is greater or equal to 0, its displacement x meters from the origin, and its velocity is given here. If initially, so when t equals 0, basically, the positions x equals 3, then t equals what? Really not too bad, because look, we want to get it in terms of t. Well, we know velocity is just same as dx dt, yeah? So we can replace that velocity with this. And can you see how it's in terms of x? Yep. I'm going to reciprocate it because I want to get dx at the bottom. 1 over 9 plus x squared. And I want to anti-derive it so I can get the time. So that's what we want. It's time equations. T is equal to what? So 1 over 9 plus x squared dx. Of course, we're going to get a c value and stuff. We have to do the c and we have to sub it in. But guess what? We can just do it in one step. So what we can do is we can sub in our initial x, our x0, and because it's in terms of x, we can put x on top, plus your t value, so your t0. So for example, can you see how our initial condition is what? When t equals 0, our x equals 3. So let's sub those in there. So x0 would be 3, our t0 would be 0. So put this here, it simplifies, it's going to already like write it in terms of, it's going to give us our c value and the whole equation. So put that in our CAS. 3tx 1 over 9 plus x squared dx. The 0 is not included. There it is. So It's 1 over 3, 10, which looks like C, 17C. Done. Probability, let's do this. So it says, it is believed that the average lifespan of people in Okinawa is 80 years. A random sample of the lifespans of 200 of these people had an average of 84 years. And one-tailed statistical test using a 5% level of significance is to be carried out to investigate if this result provides evidence that the average lifespan of people in Okinawa is greater than that 80 years. Which of the following statements would form a suitable null and alternative hypothesis for this test? This is just beautifully, this is too easy. So we know that your null hypothesis is that there's no change, so that the mean, so the average is 80, so it hasn't changed. Well, your alternative hypothesis is that there actually is evidence, so that the mean is actually greater than that 80. So that's it. Which one looks like that? It looks like E, 18E. Really easy mark, wow. Question 19. X and Y are independent random variables with variances of 3 and 7 respectively. Given that the random variable Z is that, the standard deviation of Z is what? Oh my god, this is actually really nice. So we know they gave us that the variance of X is what? 3, and the variance of Y is 7. Okay, so we first, to find the standard deviation of Z, we need to find the variance of Z, which is basically finding the variance of this whole expression. Plus 5. So, okay, to find the variance, it's a little bit different because what these constants get squared. So, like, can you see how this one here? It gets squared, which is 4 var of X. This negative 3 gets squared, which is positive 9 var of Y. But when you have a constant, the variance of a constant is 0. So, we don't include that. And so 4 times the variance of X is 3, plus 9, the variance of Y is 7. So that'll be 12 plus 63, which is 75. And of course, this is your variance of Z. To find the standard deviation, you need to take the square root of that 75. Done. So let's do that in our CAS. 75, enter 8.66, which looks like 19C. Next question. In order to gain an accurate assessment of a patient's blood pressure, a doctor asks the patient to take 16 blood pressure readings at random times. The readings are measured in millimeters of mercury. The mean and the standard deviation of these readings, so the sample means that, and S is that, assuming that the patient's blood pressure readings are normally distributed with a mean of this and a standard deviation of 10, and 99% confidence interval for mu is closest to what? A generally beautiful question. We can just do this with our CAS. We've given us every information. We just have to put in our CAS. So go and straight away menu, statistics, go to confidence interval, and go to Z interval. We're dealing with stats here, and okay. So we're dealing with 99, so put 99 here. So what's our mean? Well, we know our mean is 10. Our sample mean, they gave us 125. And how many people? 16 readings they did. Control Enter. This is your C low and C alpha, which looks like from our answers, 20 is B. Beautiful. What an actual beautiful paper. Not too bad. Overall, the multiple choice are not too bad. So I hope this video helps you with studies. And yeah, good luck everyone. Bye-bye.